This is my recreation of the paintbrush mechanic from one of my favorite games of all time called Okami. The brush feature from Okami might just take the cake as the coolest feature I've ever seen in a game. It's such a unique way to interact with the world, and it can be used for platforming, puzzles, and combat. I've been fascinated by this feature ever since I saw it, so when I had to choose what to do for my specialization project at my game programming school, this was the first idea that popped into my mind. I picked out a few techniques that I wanted to implement. Among those were sun, moon, slash, and bomb. Our school gave us 5 weeks for our specialization project, so with that I got started.
What the dog doing?
I chose to implement this in Catbox, which is a game engine that I made in C++. It is heavily inspired by Unity and had been in development for about a year. If you want to try implementing this in Unity, it would definitely be possible as well. However, this isn't going to be much of a tutorial, but I will go through the steps and explain how I did it. I will also link a GitHub repository containing my code in the description. I started out with setting up a game scene for the player to move around in. Coming from a game development school, I was lucky enough to be able to borrow some environment assets and this adorable Shiba Inu model along with some animations. The students at the game assembly are very happy to collaborate and help each other out with their specialization projects, which is really nice, as this wouldn't look nearly as good if I didn't have these assets. Conveniently enough, I was also able to reuse some movement and camera code from a different game project that we were working on at the time. After making the game scene, I created another scene, which is where I started working on the painting feature. All it contained was a plane for the painting canvas, a camera, and a cube which followed the cursor. In order to draw to the texture, you send in the cursor position relative to the canvas, where the top left corner will represent 0, 0, and the bottom right will be whatever resolution you set your texture to be. By accessing the pixel at this position, you can change the color of it to be black, as well as all of the pixels around it within a certain radius. You could change it to any color you want. I also made this rainbow gradient brush just for fun. If you are using Unity, you can use the texture2d.setPixel function. In C++, it's a little bit more convoluted than just calling a function, but it still uses the same concept. With this, you have some very simple drawing functionality. One thing to note is that if you move your cursor very fast, you will get these gaps in your brushstroke because you are skipping over several pixels in one frame. By storing your cursor position in the previous frame, you can get the distance between the previous position and the current position, and then use a for loop to paint all the way from the previous position to the current position. I also made it look a bit more paint-like by multiplying the radius with a randomness modifier, as well as a modifier based on how fast you are painting. I modeled an Okami-style paintbrush in Blender to replace the cube with. As polish, I wanted to try to procedurally animate the paintbrush by using a vertex shader. I added vertex paint data to be able to procedurally animate the brush. If you don't know, vertex paint is color data that is stored on the vertices of the model. The wooden part of the brush is painted black, while the tip has a white gradient. Since black is represented as 0 and white as 1, you can use this to influence which vertices should be affected by the procedural animation. So I created a vertex shader and offset the vertices using a vector which points in the opposite direction that you are painting in. If you are moving the brush to the left, you want the vertices to move to the right. I also offset the vertices on the y-axis to make the brush get squashed when you start painting. There were a couple of funny results while I was trying to get this to work. I accidentally made a squash and stretch animation in the vertex shader. It wasn't intentional, but it looked good, so hey, I'll take it. I also added a little paint splash particle effect for when you start painting. In the end, I wasn't super happy with the way that the vertices are deformed, but I think it's good enough and definitely nicer than a static brush. After finishing the painting functionality, the next step was to interpret the drawings into something that we could use in code. For this, I used a popular free open source computer vision library called OpenCV, which provides functions for training AI to recognize images or drawings. I was thrilled that I was able to get it set up and working rather easily with the help of a tutorial that I found. However, I noticed that the accuracy was not the best, to say the least. After some research, I found that the KNN classifier that was used in the tutorial is actually not very good for character recognition. Some more commonly used classifiers are CNN and SVN. CNN is good to use with large amounts of training data, while SVN is easier to train on a small dataset, which is perfect for me since I create my training data manually, so it's not going to be very big. After switching the KNN classifier out for the SVN classifier, I was able to immediately notice a big improvement in the accuracy. So now we have a game world and we have a canvas with painting functionality, but how do we combine these? I brought the painting scene into the game scene, and when you press the button to start drawing, the game scene is disabled entirely and the painting scene is enabled instead. When you start drawing, you also have to save the current frame to a texture and then use that texture to project it onto the canvas. I used a pixel shader to first turn the screen texture into grayscale and then applied a bit of a brownish tint to make it look like paper. Then you can simply overlay the painting texture on top. And now we have this cool switch from the game world to the painting mode, and we can draw onto the canvas like before, making it look like we are actually drawing in the game world. I'm gonna talk a bit more about the technique implementations now, which is more just general gameplay programming, so if you want to skip ahead, you can go to this timestamp. The functionality for the techniques themselves is very simple. For the sun and moon, all that's done is just lerping the sky color between a bright blue and a dark blue color, and also blending between two post-processing profiles. The bomb is spawned in for a prefab. After 3 seconds, the bomb explodes and checks for any breakable rocks in range, and then calls a break function on them, which changes their model to broken rock pieces and lerps their material alpha value to gradually make it transparent. For the trees, I used the bounding rect area of the slash symbol, and then used a for loop to cast rays forward and detect if there is anything within this bounding rect. If the ray hits a tree, the intersection point is used for spawning in a slash animation effect, and since the tree is split into 2 separate mesh parts, you can just lerp the rotation of the upper half to make it fall over. After finishing implementing all the techniques, I realized that I had quite a bit of leftover time, so I decided to implement yet another function. I wanted to try making lily pads. The thing that's interesting about the lily pads is that it's not just another symbol with a different implementation. It actually uses a circle, which is the exact same symbol as the sun. What differentiates them is where you draw them. If you draw the circle on the sky, it's the sun symbol, but if you draw it on water, then it's a lily pad. So how do you detect which surface you are drawing on? When you start drawing, a screenshot is taken of the game in its current state. But a screenshot is not only taken of the colors of the screen. There is another screenshot which has all of the game object IDs stored. Each game object has a unique instance ID, so if you have a texture with all of the game object IDs, you can just sample from this texture to get the game object that is currently being hovered. I created a particle system with blue spirals, and they will emit as long as you are hovering over water. The information of what surface you are drawing on is sent along with the shape you drew. Then you can check if you drew a circle, but also on what surface you drew the circle, and if it's on water, you can instantiate a lily pad prefab. There is more potential for surface detection. For example, in Okami, you can draw on fire to light torches. And that was all I did for my specialization project at my school. Like I said, this was done over the course of 5 weeks, and I was very happy that I was able to stick to my planning at all times, and I managed to accomplish everything that I set out to do, and even a little bit extra with the lily pads. I feel like I created something really cool, and I also got to experiment and learn a lot in the process. And not to mention, I had a ton of fun developing this. Thank you for watching, I hope it was at least somewhat interesting, and I'll see you next time. Bye bye!